A couple of things we're going to talk about today. You'll see the weather fundamentals. We are going to go through a couple of those. If it is review, great, because everybody can always use a good review, especially on the weather. And then we are going to talk a little bit about pilot reports. We'll go through the air traffic control services. We want to talk to you a little bit about how you can actually work with air traffic control to have them help you or better communicate with them to further your weather knowledge and when you're flying, to understand what's really going on. And we'll go through some VFR tips, IFR tips, again, that practical side of it as you're flying. So the first thing we want to go through is, everybody, if you've taken your private pilot knowledge test, you remember the root cause of all weather is the sun, okay? So the sun heats up the earth, and I think most pilots, most people in general, don't appreciate how much this is, how true this is, and how much of an effect it really has on our flying. So obviously, the sun heats the Earth's surface warms up, and it heats the air that is directly adjacent to the surface. And that starts a whole series of processes. The first process that starts is what we call a convection. And basically, we are going to have warm air at the surface that's going to be, it's going to rise up. As it rises, it's going to condense. The air above is cooler. And as it condenses, it will at some point start to form a cloud. It will condense out, the moisture will condense and form the cloud. And then that cooler air will then sink back down, and then it warms up, rises, sinks. It's the basic principle of all the clouds you see and all the bumps and lots of things, start from this process. So this convective action is very important in understanding how it actually works throughout the day. So we're going to go through here. You'll notice, I'm just going to use a sample here, about 9 a.m., your convective layer will be anywhere from 500 to 1,000 feet, okay? You early morning risers, there's a few of you in here that like to get up way too early and go fly, but the reason you like to do that is because it's absolutely smooth. The reason it's so smooth is because you get up right at the crack of daylight. The sun hasn't been up, and it hasn't had a chance to do anything. That air is completely smooth, okay? It hasn't had a chance to start doing this. By 9 a.m. or so, 9, 10 o'clock, you're starting to get some convective action. Again, that 500, it's up to about 500 foot to 1,000 foot that air is rising and sinking. So anything below that layer, down here, is going to be turbulent, bumpy. It'll get worse as the day goes on. It won't be too bad in the morning. You'll start to feel little bumps and chops. Of course, if you're going to give rides, if you want to enjoy your flight or taking somebody new up for a flight, this is the time to do it, before it gets too bumpy. So take that into consideration. I still see pilots that take people for a ride at 1 o'clock in the afternoon, and people come back and go, yeah, that was kind of fun, as they're, green in the face and heading for the bathroom. So we want to avoid that. We like it. We want our passengers to have fun, enjoy the flight. So now if we watch as the day goes on, that convection keeps going. As the sun keeps heating up their surface, that air keeps rising. As the air gets warmer, it rises further, okay? As the air temperature on the ground increases, it allows that warm air to then rise further up. So throughout the day, that convective layer, the height of that layer will increase. Now, again, we said it was going to be kind of bumpy underneath it here, and that's because this air underneath here is unstable air. Because it is rising and falling, it's an unstable layer of air. Above this, it is very, very stable, okay? We're excluding all other factors at this point, but typically very stable air. It'll be smooth as glass. So when you're flying, you can start out your day. If you're heading to Utah, you can take off and fly at 3,000 feet till about, about noon. And then at 3,000 feet, you got to climb it to 5,000 feet, and then to stay out of the bumps. And, of course, if we're in Iowa, we've all seen this before. By 3 o'clock in the afternoon, we see these things come rolling through, and they're big dark clouds. At this point, we can no longer outclimb it. We're now dodging them, going around them, okay? So the convective action will increase to the point where you actually saturate the clouds. It will get to the point where the clouds are fully saturated. They cannot hold any more moisture, and that will eventually cause it to then precipitate out, also known as rain, out the bottom. And now, a couple things about this. We're going to get into the thunderstorm just a little bit, mostly because it's so prevalent here in Iowa, and a lot of guys are either too scared or not scared enough of thunderstorms. So we're going to try to balance that out a little bit. So again, the air underneath here is turbulent due to the rising and falling air. When you get an extreme updraft, okay, the air rising up, and then extreme downdraft from the thunderstorms, from a large convective action that's causing a thunderstorm, this same action you see down here is actually happening up inside of the cloud. That's very important to remember, okay? The reason that we get bumped around when we go through the clouds, I mean, I'm sure everybody in here has flown through a cloud at some point, whether IFR or VFR, and we're all guilty of it. But you all know from experience that if you fly through a cloud, you get a little bump every time you go through a cloud. Even if it's this little guy down here, you get just a little bit of a bump every time you go through, okay? And then you get a little bit bigger bump going through this one, and you really get a bump going through that one. Now, the reason you get that is because that air is churning, and you can actually, it's just a really neat sight. If you're flying along the tops of the clouds, and you can watch the cloud boil over. You can see that action happening. You see it bubble up out of the top. That's the warm air rising, condensing, forming the cloud, and falling back down. And the same action here, except in extreme version. Now, hopefully not from experience, but does anybody know the exact updraft, downdraft capability of your typical thunderstorm? It's huge. Yeah, we're talking anywhere from 2,000 to 3,000 feet per minute. Okay, so you're flying along, and all of a sudden you enter the cloud, and you'll hit a 2,000 foot per minute vertical updraft. Okay, and immediately, within just a few seconds, you're going to experience a 2,000 foot per minute downdraft. Okay, so a difference of 4,000 foot per minute. Now, you experience that, and especially if you're going the wrong way through the cloud, you can hit a series of those, okay? And that will not do a lot of, it'll do a lot of things to the airplane, but nothing good. I just want to share a short story that I had heard, I'd read in a IFR magazine that there was a Cessna, a student and instructor down in Florida, went out flying. The student had done a preliminary weather check. The instructor had not, and down in Florida they get the same thunderstorms we do, but they pop up a little more quickly and they dissipate a little more quickly. They just it's a little more violent just due to the increase in temperatures and the extreme moisture down there around the coast. But so it's not uncommon for these thunderstorms to pop up. And they took off. They were flying, doing their lesson, and immediately within 15 minutes of taking off, the nice sunny skies turned into big buildups all around them. And they were on a cross country trying to get to another airport further north in Florida, and they had to end up filing IFR, which they were both, the student was instrument rated. I think he was working on his instrument at the time. They ended up filing IFR and going through some of the layers. They did not have any capability to see the weather. They're just in your standard 172. And as they're going, they're starting to get bumped around pretty good. So they called up air traffic control and said, "Hey, can you tell us what's going on? We're in and out of the clouds. We can't see anything. We're not sure where the bad stuff is." And as we'll talk a little later, air traffic control came back and says, "Yeah, I think if you head this direction, you'll be okay." Okay, well, that's helpful, kind of, maybe. So they continued on. Well, unfortunately, the controller was really busy at the time, and he didn't really, he had a lot of other things to worry about. And he actually sent them directly into a cell, okay? So they ended up going through a severe cell, a very, very convective cell, which actually had extreme microburst potential, and actually they found out afterwards that there was microburst coming out of this particular area of the cell, which a microburst is just an extreme version of those updrafts, downdrafts that we were talking about. And the next call to air traffic control was an emergency call, stating that they were getting rocked around to where they were losing complete control of the aircraft. They could not control its direction, its altitude, anything about the aircraft. They were just along for the ride. The controller started paying a little more attention to them at that point, and gave them a vector to get out of it, which at that point they'd already basically gone through most of it, and they were already coming out the backside. So they were in the cloud for about a whole minute and a half. Okay, now in the worst part of it. Now, a minute and a half is a long time when you're getting bounced around. amazingly, they actually made it out of the cloud, out of the storm system. They came out the backside. The downdrafts, updrafts and downdrafts had actually taken the tail, the horizontal stabilizer, and had bent it down 30 degrees on the left side. It blew out the back window and the side window, and their struts were both bent on both sides. And they were still flying. They still had full control of the aircraft, minus a little bit of a quirk with the tail and its controllability, but everything still worked amazingly. They were able to find an airport and land. Now, I think that's a little bit of a testament to the Cessna aircraft. That's it is a very tough aircraft, and that just proves how tough they are. But they were extremely lucky. So that's just an example of what can actually happen in the middle of one of these thunderstorms. So for those of you who aren't respectful enough of them, that should hopefully cure that part. But I also want to explain, how we can actually work around these, because we don't need to just stop flying every time we see a dark cloud in the sky, but we need to know what the potential is. So obviously we want to avoid these. Now I'm going to show you some different types of the clouds, and I'll probably come back to that slide a little bit, but I want to go through a couple of different types, and then we'll talk about that thunderstorm life cycle again. Here's an example of some of your light cumulus clouds. This is an early morning flight, so this is 6 a.m. Okay, so it's exactly what you're going to see. These light wispy clouds. They're 1,000 foot above the ground. This particular layer is actually being caused by a front that's pushing through with a high pressure behind it. That it was causing this layer. You'll see it thickens up here in the back. But these types of small clouds are exactly what we're talking about. I'd hardly even consider that a cloud. I mean, really, as far as even for VFR flying, you're well clear of everything. But if you consider back here where it forms up a little tighter, these are stratocumulus clouds, and they're a little thicker here, and that's your typical just thin overcast layer in the morning, especially after you have some fog. You'll get that little layer that's hanging up higher. The visibility, once the visibility starts to clear up, you still have that little layer. In fact, it was here this morning. There was a little layer as you might have been driving to the airport, and it finally just broke up and lifted and went away. That's very typical, especially around our area here. That same layer, and then you go a little higher, and these are your alto cirrostratus. You can call it the alto stratus or cirrostratus, either one. Basically, your stratiform clouds are just your flat, smooth, clouds. Not a whole lot of turbulence associated with them, just very flat, thin layers. Nothing to worry about. And they can be in all forms, from your just light cumulus to the alto or cirrostratus. The alto stratus would be the higher up versions that most of us aren't getting to in our normal flying. They're pretty high, above 20,000 or so. Then we go to the mid-afternoon, midday, and we're going to start seeing your typical cumulus cloud. Okay, and as noted here, these are the developing cumulus clouds. So this is when you're starting to see what we call vertical development. Okay. This cloud is a little more of the bump when you go through it. This is where you feel the good bump. Still perfectly capable if you're an IFR aircraft and you're on altitude and you're cruising, and the clouds are slowly building up and they start getting up into your flight altitude. You're going to start kind of punching through the tops of these things. They're perfectly fine. They're not going to hurt any aircraft unless you're flying on ultralight or something. But I don't know many IFR certified ultralights, so. But they don't hurt an aircraft. There's just a little bit of updraft, downdraft to them. They are big. I mean, your typical airplane is, for size, is about about that big in the cloud. So one thing I want to note though on this picture, it's kind of a unique view. You'll see, and you can actually see it in each of these, where the color changes just slightly on the bases of each of them. And then if you look out here on the horizon, you see that flat layer. That's not the horizon. That's actually the air boundary. So when we're talking this unstable air that's below, the convective layer below, and then that stable air above, that's your boundary. So this is unstable air below, and this is your stable air, very smooth air right above it. And the tops of the clouds will peak above that, and that's where they'll stop. They'll typically go just above it, the little momentum with the updraft. But all you have to do to get smooth air is just get above that layer, and you're good to go. You can cruise all day up there, unless we have some other pressure systems causing turbulence. Typically, that's very smooth air. So just something to watch for. And again, that rises as the day goes on. So don't expect to keep cruising at 3,000 all day long. You're going to need to climb an altitude to maintain your distance above that layer. And finally, we have our cumulonimbus clouds. This picture was taken by a local pilot, I think last spring. He was at 23,000 feet, looking down on this, although it's not very much down. The tops of those clouds were actually just shy of 20,000 feet. So just to show you the vertical development capability of those cumulonimbus, the same clouds we just saw, this is what they look like once they're fully developed. Now this particular cloud, it has a unique perspective because this cloud is actually dissipating. Okay, this cell, this storm system is actually dissipating. The way we know that is that you'll see it starting to break up on the back side. Although you see the trail, the vertical development trail, as it's starting to blow away, it's dissipating underneath itself. If they're still building, they'll be completely straight vertical. They may have an angle to them, but it'll taper off, but you will still have a straight column underneath where that rain is still, that pocket of rain is still just sitting underneath the cloud. Here it's all gone, it's all dissipated out, so you're just getting the remnants of it. And also its altitude is not as high as it probably was an hour or two earlier. Most thunderstorms will reach way high up. Some of them can actually reach up into the troposphere, but most of them are 30 to 40,000 feet. So we're not going to outclimb these. Typically, we're just going to navigate around them. Now, some ways to navigate around the storms. If you're flying an older aircraft with older equipment, you're going to have a storm scope. I don't know if anybody has a storm scope or has ever used one. A strike finder or a storm scope, the same thing. They just detect lightning strikes, and that'll give you the kind of the core center of the storm where the lightning is at, and that will help you to see where the center of the cell is, and that will allow you to kind of deviate around it yourself. Otherwise, typically you're not going to know exactly where the cells are at, and especially if you're IFR and you end up getting in the clouds. If you're IMC, you can't see these individual cells and tell where they're at. You're going to have to basically guess if you're in the clouds, and that's a little harder to do. So you're going to want to use other weather sensing devices. If you have onboard weather, which I think a lot of people now are probably starting to get that with Garmin and XM Weather, you have the live weather radar and that sort of stuff. So that's excellent. Nowadays we're kind of getting spoiled with everything as far as GPS and weather, but still just the ability to kind of visually see what you're looking at and tell the difference, that's very, very important.
Is that ADS-B, does that show anything?
Yes. Yep. The ADS-B will actually provide weather, although the system, I'm not sure exactly how well it's transmitting back yet, just because not everybody's using it. I think everybody can now. I think that's one of the features you can get now with it is that you can get the weather. You can get traffic, although the traffic is not great because it's only whoever's transmitting. Most people who have the receivers, they receive it. They're not transmitting their data out. So as far as like traffic goes, you're only going to see the people that are transmitting, which there's not very many. But I think as far as I know, it is transmitting the weather right now. You know that you will receive that information if you have the proper setup. So that's going to be very handy, and that's a free service. It's if you got to buy the receiver, but everything else is free. So that's a very nice feature for all of us. I think the deadline, 2020, I think is when we have to have. We're all going to ADS-B. So when we switch over, then that means everybody will have to be transmitting, which means your traffic will be much better. Right now, if you get the ADS-B traffic, like I said, it's good, but don't rely on it because you're only probably getting a fraction of what's actually out there. So, a couple of things I want to talk about in the thunderstorm here. As you'll see this flat layer, everybody sees this flat anvil top on the top of the thunderstorm. Does anybody know what causes that? Is there any ideas? Loss of momentum. Part of in this stage, yes, that's going to build it down. But actually, what shapes it initially is the jet stream. Okay, so when these clouds build up to 30, 40,000 feet, when you see that anvil top up there, you're looking at a cloud that's at least 30,000 feet up. That's actually being sheared off by the force of the wind at 30,000 feet. It can no longer maintain its vertical development. It's just getting pushed over by that strong wind. So that's kind of neat when you're just walking outside and you look up and you tell you're looking 30,000 feet up, you know how high you're looking, at least, if not higher, and to know that the wind is that strong that it just shears off those clouds. So another thing that will cause it, in this case, as it's dissipating, that's bringing it down to 20,000 feet, is basically the saturation of the balance level, the balancing point where it's cold enough here that it just won't form any higher. So it'll just flatten out and pancake out. That's when you get this kind of mushroomed out cloud effect. When you see the absolute shear where they really are, that what we would classify as the anvil top to the cloud, that's the jet stream. But the mushroom or the pancake look is basically, that's just the height of it. So in this aircraft, if you're pressurized and you're going above 20,000 and you see this, you know that thing is done. It's not going to go any higher. You can actually jump over that in that case, but it's already dissipated. So really, even flying through these types of clouds, if we were down here in our smaller GA aircraft, you can go right through that. You're going to get bumped around, but it's not going to hurt the aircraft. You're not going to have the severe turbulence that you would normally be associated with it. So any questions on the types of clouds? Anything else? Okay, let's go through temperature just a little bit. Again, there's a couple of key things that are very important to understand from a practical side of things. We know temperature, is the root force of all weather. It's, as the temperature changes, that's when things happen. And temperature is just the measurement of the average kinetic energy of a substance, of the air. So it's basically how much potential is in it. So the warmer the air is, the more kinetic energy it has. If it's colder, it's very dense, the molecules aren't moving, it's very stable air. Okay? The stable and unstable you're going to see has a lot to do with how we interpret the weather forecast. So as we get colder air, more dense, more stable. We've experienced that all winter long. Nice, if it wasn't as cold as it was, we could have gone and flown. If it wasn't as windy as it was, but if you were able to get up this winter, it's very nice, smooth air because it's very dense, it's very stable. Even down low, you don't get a whole lot of turbulence as long as the wind isn't blowing. That cold air is very good, and the reverse for the warm air. Now, the chart here is going to demonstrate temperature and dew point spread, and this is relating back to our thunderstorms and our clouds that we were just talking about. A little trick that you can tell about when you're going to get rain, when you're going to get clouds. You can watch the temperature and the dew point. Now, before we get into this, we should probably explain what dew point is, because a lot of times there's a misconception on dew point. Dew point is simply the point at which if the air temperature, so let me give you an example to make this a little easier. If the dew point was, say, 60 degrees, the temperature was 70 degrees. If the temperature were to suddenly drop to 60 degrees, okay, the atmosphere, the air would be saturated. It would no longer be able to sustain it, and it would now precipitate the moisture that's in the air. Okay, so the dew point is the point at which the air can no longer hold the moisture, and it's going to precipitate out. So with that being said, if we watch the spread, as in this graph here, you see as we go along and throughout the day here, the temperature as it cools down, okay, and it's cooling down because we're probably having a cold front coming through, it's starting to cool off, and the dew point will start to increase. And the reason that's happening is we're getting a big pocket of moisture that's moving in, and as the temperature decreases, the gap closes between the two. Now, when you get right here within about a 2 to 3 degree spread between the temperature and the dew point, you can expect moisture in the air in the form of fog, haze, clouds, low-level clouds, specifically low-level. Okay, it's not going to indicate that you're going to have clouds up 20,000 feet. We're too far away. We're measuring on the ground. But if our ground observations are measuring a spread of simply 2 to 3 degrees, I guarantee you can walk outside, and if it's not foggy, hazy, you're going to see low-lying clouds off in the distance, and they're going to be coming your way pretty quick. So that's the first indication that you have some sort of adverse weather moving in. The final indicator, which is pretty definitive, is when the two numbers match, okay, within 1 degree or when they're matching. At that point, you're going to have rain. I will bet anybody, anytime, forever, that when these two are matched, if I'm reading the AWOS out here at Independence, that we can go look out the window and it's going to be actually raining, snowing, sleeting, or severe fog. One of the two. If they're matched up, if the temperature and dew point are the same, it has to have visible precipitation out there. So that's one way to see when the rain's coming, as if the fog's rolling in. if you're a pilot flying along somewhere, this is your indication that something bad's about to happen, okay? Especially at night. We can't see clouds at night until it's too late, till they're blocking out the lights below us when we're over the overcast and it's too late, or until the fog sets in and now we're in this black abyss, okay? So when if we're doing our job, we're paying attention to the weather as we go along. We always have to get our altimeter updates, barometric pressure updates as we go along. And as we do that, we should be listening to the AWOS typically, unless air traffic control is giving it to you. But as you're listening in, pay attention to that temperature and dew point. It's one of those things that I think a lot of pilots just kind of let slide on by. They don't pay attention to because, it's warm out, it's cold out. Okay, good enough. But look at the spread, because that'll tell you a lot about what's happening around the area. Especially if you notice that off your right side, every station reporting off one side of you to the north of you, say, is reporting a spread that's getting closer. That's telling you that something's moving into their area, which could be heading your way. You can actually follow the path and the trend of these systems as you watch the stations. This requires a little effort on your part, but it's well worth it, especially if you're flying at night VFR and there's a forecast for potential fog or rain or low level clouds. This will give you the indication. If the reporting stations immediately around you start getting within a couple degrees spread, I would be finding a place to land if you're VFR, and even if you're IFR, because especially at night, around here we get some pretty good fog. So we don't want to be caught out there in the fog. That's not good. There's lots of guys have had some bad accidents because of that. So one more thing on the fog, since we're on the topic. At night, I know there's a couple of pilots in here that know this rule, but if you're flying along and you start to see a haze around the lights, the halo, little ring around the lights, that's an indication that you're going to get fog. Okay, that's an indication that basically you are minutes away from fog rolling into the area. So if you're flying at night VFR and you see that the halo start to form around the lights on the ground, find a place to land immediately. You can get a hotel room, no big deal. You'll be happy you did the next morning, because the alternative is not real good, because that guarantee you that means there's fog coming. So keep that in the back of your mind. Any questions on the temperature and dew point? Okay. Temperature and density. Okay. Temperature affects the density. Okay. The colder the air, the more dense the air, and the warmer the air, the less dense. Okay. As we've seen, the less dense air wants to rise. That's what starts that convective action. Moisture actually reduces the density of the air. This is a very common misconception. As you'll see here, if we have a bunch of air molecules and there's a low level of water, we have low humidity, and if we have high humidity, simply because the water molecules are taking up more space, in the air, we don't have as much room for air molecules. That means the air is less dense. The air is less dense. Yes, to us it feels like it's thicker, heavier air because it's very moist air, especially in the summertime when it's very humid. We think the air is thicker. It feels to us it does, but that's thicker combination of water air. That's actually less air. Now, the reason that's very important is because that affects our performance. Okay, and this is another hot topic that I see a lot of pilots getting into trouble with. Is you're flying along, or you're going to go for your flight, and I've seen guys go out on a nice, very, very, very warm summer day around Iowa, and we all know around here it gets very, very humid, and they don't consider that in their performance, the aircraft, either takeoff or landing, particularly takeoff. That's the key one that'll get you, because you haven't had a chance to get up and realize what's going on until it's too late. So if you have a warm summer day that's very humid, that's going to drastically affect your takeoff performance, and you need you really should be running the numbers. I mean, you should every time you fly, but especially when it's getting hot around here in Iowa. This really, I can't express enough how much an effect this has on diminishing your takeoff capability. So don't just think because it took off yesterday with everybody on board, it will today. Now, going back to this humidity, I want to point out the difference between dew point and humidity. Again, often these are confused as being the same or or mixing and matching the definitions. But humidity is our perception of how much moisture is actually how much moisture is in the air. Dew point is the measurement, is the point at which the air will become saturated. So dew point, again, when we go to temperature dew point, the dew point is going to let us know how close we are to becoming fully saturated, but the humidity is actually our measurement of how saturated it is, okay? So, and then to break that down some more yet, humidity to us, we talk about relative humidity. That's what the weatherman reports on the news. That's great, but that's not exactly what really affects us, okay? Yes, it does. You know, the more, like we said, the more humid it is, that it's going to affect our performance. But to actually run the numbers, we have specific humidity, there's absolute humidity, and then relative humidity. And the absolute humidity is the actual measurement of how much the ratio of water to air, of what it can hold. So if it can hold X amount of water in the air before it saturates out, if it's 10% of that, then we have a 10% relative humidity. The absolute is an exact measurement of what that is. Again, to us, the exact numbers aren't really critical. That's why we don't ever get into it. That's why your textbooks probably never talk too much about it. But understand that humidity is different than dew point. So we need to understand when it's high humidity, that's affecting the density, okay? But the dew point is going to tell us when we're actually going to develop rain and that type of stuff, and based on what the air can actually hold. So let's talk about pressure systems. Yeah.
So, you're saying that increased humidity decreases the density of
It decreases the density of the air, which will increase our density altitude. Higher humidity decreases the density of the air. It will increase the density altitude, which, yeah, the key thing is the higher humidity results in a lack in performance, a decrease in performance. Yeah, I think so, maybe. Yep.
High humidity, more water, which is heavier for a given amount of volume.
Well, it just takes up the space. It's actually not. That's the key thing, yeah. Yep. So the key thing is it just takes up more space. So if I can only fit so much material inside of this square, if there's high humidity, the water's taking up space that could be air. If there was more air, that would mean it's more dense.
What they're saying is the water molecules are lighter.
Yep. Yeah. That's kind of a key thing. Yeah. Again, that's a very easily confused thing because a lot of people you think water is heavier than air, but the water molecules are actually lighter. Yeah, water vapor, yeah. Yep. So that's why I want to bring that up, yeah, because it does drastically affect performance for us. So,
yeah. So a hot, dry day, you can take it off shorter. A hot, humid day, it's going to take a lot.
Correct. Exactly. Yep. So down in Texas, when it's dry as in Arizona or somewhere, it's 120 degrees. I'm not. These aren't exact numbers, but the idea is that it could be 100 degrees in Arizona, dry as a bone. And you run your performance numbers and say it takes 1,000 feet. You come with 1,000 feet to take off. You come back to Iowa and it's only 85 degrees. It's cooler, but it's super high humidity. It might take you 1,500 foot to take off. So at the first glance, it would look like you would think that you should have a better takeoff performance with the lower temperature, but the density drastically affects that. And it affects it in more ways than one. It's not just the airflow over the wing, okay? Because we want air molecules, not water molecules flowing over the wing. But it affects the engine. I mean, the engine's taking in air, and if the engine's taking in half air, half water, well, it's not doing us a whole lot of good. We've decreased the performance, the output capability of the engine as well. So, and then finally, the propeller again is an airfoil. Okay, so you have the propeller, the engine, and the airfoil that are all being reduced in performance capability. That's going to result in a drastic decrease in overall performance. So very important to understand that, and very commonly misunderstood by your basic pilots. So, all right, I want to make sure everybody understands that. Yep. High pressure and low pressure systems. Now, high pressure systems, as we've noted here, are associated with good weather and cold air. Low pressures are bad weather and warm air. Now, what is a high pressure system? Right? A high pressure system is not a bunch of air that's high and other air that's really low. It's It's the amount of pressure. So as air warms up, its pressure increases or decreases? Decreases as it warms up. As it cools down, it gets more dense, its pressure increases, okay? So again, everything comes back to that action from the sun. As the sun heats the Earth's surface and heats the air, that starts a chain of events as far as temperature, pressure, dew point, everything. It really has a big effect. So the high pressures are simply areas of relatively high pressure. Okay, if the sun did not heat the Earth's atmosphere, heat the Earth, and then resulting heat the Earth's atmosphere, our atmosphere would be the exact same pressure. From here to Paris to Tokyo, it'd all be the same. Okay, we're going to take out some other variables, but we keep it simple that that it would all be the same pressure, same temperature, everything. But as soon as you heat up one area, okay, so let's just say Texas is further south, the big, lots of open brown dirt, sand, rock, and it heats up really, really well. So it gets really warm, heats the air above it, and all the air around Texas gets really, really, really warm. That air is going to do what? It's going to rise, it's going to expand, it's going to become less dense. It's going to create a low pressure, a relatively low pressure compared to the air all around it. Okay. At the same time, up in Minnesota, you're going to have a bunch of air that is cooled down by snow, ice, whatever, just the colder temperatures, and that area is going to become more dense. The air is going to become more dense, more compact, and that's going to create a relatively high pressure area relative to the air around it. Okay, and then you compare the two together, and you get a relatively high, relatively low pressure. That's where this all starts, and it happens all the time, all over. It doesn't have to be just north and south. It can happen, all over. It's just a matter of temperature and differences in temperature that then change the pressure. Now, the high pressures, because it's a high pressure, it tends to flow outward and downward, okay? So the air will flow out and down, and it will rotate in a clockwise manner. And the high pressure will have, like we said, good weather and cold air, okay? The low pressure goes reverse. It's going to flow counterclockwise, and it's going to flow inward and upward, okay? That rising warm air inward and upward. The directional rotation and the flow, whether inward or outward, this has a huge impact to us practically when we're flying, okay? So we're going to take a look at that in just a second on how that really affects us. One thing else I want to note is the standard pressure at sea level is 29.92 inches. If you're a private pilot, you should have that memorized. If you want to be a private pilot, you should have it memorized. So now we also have 1013, 1013 millibars. That's the international standard. We don't use millibars, we use inches of mercury. So on weather charts, and we'll see some here after a little bit, you're going to see millibars listed. So don't let that confuse you. It's just a different standard. This is the standard at sea level for millibars. So basically, if we have a higher number than 1013, it's going to be a relatively high pressure. If it's lower, relatively low. So, okay, so let's just plan a flight. We're going to go from New York down to Dallas. Okay, and as we go, we're cruising along at 180 knots, and it's going to take us about 6 hours and 45 minutes. Okay, it's about a 1,200 nautical mile flight, and pick your favorite airplane. And as we go along, before we go, we're doing all of our homework, we're checking the weather, and we see a chart that looks like this. We have a low pressure and a couple highs out there, and this is just the relative positions they are today on our flight. Now, I'm already helping you out a little bit here, and we're kind of cheating. I'm showing you those flows again, okay? That's because that's important. Again, we said that those flows have a lot to do with impact our flight and how well or not so well our flight goes. Now, before we take off here, one thing I want to mention is the low pressures are associated with, we said, with bad weather, correct? Okay, and that's typically because we have that warm, moist air. It's usually a lot of times moist air, and that will then meet with cold air, and that can cause development of precipitation, storms and things. And we're not going to worry about fronts yet. We'll talk about fronts in a minute, but just the pressure systems themselves. So right off the bat, because it's a low pressure, we can already assume we're probably going to have a low pressure. or I'm sorry, some bad weather, right? So we're flying along. Let's say we are instrument rated, okay? If we weren't instrument rated, that's going to scare us away even more from wanting to fly right through that particular area, okay? Maybe we look on the radar and we see some rain showers. Even if we're instrument rated, it's very common to run into a situation where because of the bad weather, you have low stratiform clouds, you have poor visibility, haze, fog, steady rain showers that are diminishing visibility, and low ceilings, okay? From an instrument rated pilot, if I'm going to do this flight and I see that for 500 miles of my flight, it's going to be like 200 foot and a half mile for 500 miles. And trust me, it happens. It's out there on a, and if you're flying and you want to go somewhere, that's going to it should deter anybody from directly flying over that area. Because for 500 miles, which even at 180 knots is quite a long time, you now have nowhere to land. Okay, so these are things we should be considering on our flight. So as an alternate, we're going to kind of deviate our path just a little bit. So let's say we're going to go down here. We see high pressure down here, and high pressures typically equal good weather. We're going to fly down to about Atlanta, kind of bypass the worst of the storms and on around. Now we go a little bit further out of our way, okay, but we miss the storms. So that's the way it goes. Sometimes you get stuck, And unfortunately, we just so happen to have a headwind, just the way it works out. So we're only going to average 170 knots. So all of a sudden, because of our distance and our headwind, our flight's going to take us 50 minutes more, about an hour more. Okay, not the end of the world. We're going to stop an extra time for gas. Okay, whatever. I hear this from pilots all the time. Well, I have to stop again, and this is going to deter my flight. It's just a big headache for them. Well, and the reason I'm bringing this up is because I see this from a lot of pilots. They don't look at the alternatives. Because they don't fully understand the weather systems, the weather patterns. If we just deviate the other way, we're taking advantage of this low pressure instead of having the disadvantage of it. We're following the wind patterns. We also have a high pressure over here, which is going to help the wind flow. And now, because we went the right way around the pressure system, we're now getting an average of 200 knots ground speed the whole way. We've increased by 20 knots. We've actually taken off 30 minutes from the original time, or we've added a full hour and a half, taken an hour and a half off of our alternative that we were going to initially try. Okay. Not only to mention that, but because now that we have a tailwind the whole way, we know we have better weather off our right side the entire flight. So we always have an alternate place to go. We're only going, we're not going too far out of the way. And typically, if you look at the fronts, which we'll talk about in a minute, if you watch the direction and the movement of it, most of our weather moves west to east, right? So typically this weather is going to be moving this way anyway. So going on the wrong side of it can actually get you stuck in worse weather than you anticipated because you weren't ready, you weren't expecting it to move in. Also, this route that we're going, by the time we get there, because this is, we're talking a 6-7 hour flight, by the time we get to this area, a couple hours makes a big difference on weather patterns, depending on how quickly they're moving. If that system could move out of the way and actually allow us to not have to deviate at all, we go right on through and we hit that gap, but the gap will be down along our flight path and we just sail right on through, clear skies and everything's great and we got a big old tailwind. It makes a huge difference. So spending a little extra time on your flight planning and knowing the weather, really understanding it and what the weather charts are telling you can really make or break your flight, and especially if you're doing this pretty frequently. So something to think about. Now to go through the different types of fronts, we've all seen these on the charts. This is what the weatherman pulls up the chart and says, oh, there's a cold front coming through, a warm front. Okay. And he jabbers on about stuff and he's wrong all the time anyway. So, we don't know it doesn't help us at all, right? And I get a lot of guys that still, they come in and say, oh, well, I heard in the weather, the weatherman said, he said. Okay, well, I don't care what he said because he's forecasting for an entire area. He's not flying an airplane also. Okay, that makes a big difference. And he doesn't care where you're going. He just, he's trying to tell you if it's going to be 70 or 75 or 80 outside. He's just forecasting for an area. So our ability to forecast ourselves is huge. And so we need to understand what these fronts and these symbols actually mean and what they can infer, what we can infer from them. A cold front is basically associated with an area of high pressure. Okay, A cold front is going to bring an area of cold air, relatively cold air, okay? And that high pressure that's typically behind it, that's back here, pushing out on it, that high pressure is going to have good weather associated with it, okay? Now, the front itself is the boundary of that pressure system. So if we go back to this, you can imagine that, respectively, this circle is your front, okay? It's the boundary of that pressure system. That's all it is. A front is just a boundary. It's just the edge of that pressure system. And just in the same way, the boundary of our low pressure is going to be equivalent to this warm front, okay? Typically, that's what they're associated with. At the same time, I'm now going to tell you that the high pressure equals good weather, but the cold front that is preceding it typically brings bad weather, okay? The cold front is actually when we get our thunderstorms in the summertime. That's why we have the thunderstorms. Is you can imagine in Iowa, in the afternoon, it's nice and warm, super humid, we're out there sweating, and all of a sudden this big high pressure comes rolling through, full of nice, dense, cold air, and it mixes right on this boundary line with all that warm air. What happens when we mix warm and cold air, updraft, downdraft, and we have lots of moisture? Perfect, you know, the perfect storm type thing, right? You know, and so we'll get thunderstorms. You'll get a line, and we always see the line comes west to east, right across the state, typically from the northwest to the southeast. And every time it's just a line. It's a band of thunderstorms. That band is your front. That's the front. That's the boundary line. You know, understand that when you see those charts, that's what you're seeing is that front. Now, those fronts typically move pretty quickly. Occasionally they can get slowed up, but the high pressures, the cold fronts move fairly quickly. The warm fronts are a little slower moving. They don't have as much force behind them with the less dense air. The cold front itself, once it passes, that's when you get the high pressure, and that's when you're going to get the good weather. Okay? We all know, because we've all experienced it, the thunderstorm comes rolling through in the evening, 5, 6 o'clock, lightning, thunder, rain, you know, dogs hiding at the table, and then the next morning, what's the weather like? Perfect. Absolutely perfect. Just beautiful day. Okay, it's usually a little colder, right? Ever notice that? It's always colder. That's because that cold front brought that cold, dense air, and then it's a severe clear sky. It's a nice day, good day for flying. If you're smart about it, if you really want to get a good day in flying, you can sit there and watch, and while everybody else is, you know, still kind of recouping from the storm because they think that storm is still rolling through, you're out there and you know that the next morning it's going to be severe clear, it's going to clear out immediately, and you're going to be able to go fly, and you're going to have some beautiful weather for doing it. That, in fact, that cold air, that stable air will help reduce the effect of the convection, okay, because you're starting with cooler air, so it's going to take that a longer time to build up, which means you're going to have a longer time frame to go fly without getting bumped around. So just for enjoyment purposes, I mean, that right there will do a lot for you, just to know those and see them. Just to mention a couple of the other ones, that your stationary front is just the boundary between two fronts where the front is not moving. If it's just staying stationary, that's just a stationary front. It's not moving one way or the other. They do have movement associated with stationary fronts. It doesn't mean it's perfectly stationary. That's just what they call it. It just means it's relatively not moving one way or the other. It's just kind of floating around. You know, it won't stay in place perfectly, but really it doesn't have a definitive movement like these do. We did discuss the warm front. The occluded front, if anybody can give me a verbatim definition of an occluded front, well, yeah, good for you. Because I've had college professors that can't do it. You know, it's just that teach weather that can't do it. So, what it is, an occluded front is actually an area of cold air or warm air that is overtaken by a relatively colder air or warmer air. Okay, so it's kind of like a high pressure overtaking a high pressure, and the boundary between the two is an occluded front. It's very unique in how it happens. Typically, it's going to be associated with a warm front. Typically, because that warm front doesn't move too quickly. Especially, you'll see this in the summertime down in the Gulf. We'll get a warm front that comes up. We're going to pocket warm air. Nashville and that area is just getting hammered with rain showers for like a week. You know, you always see that they're just getting hammered. And we got a big high pressure that's come down through us, and we got nice weather. We're happy and hunky-dory, just everything's going fine because we have the good weather. But that boundary line is where all the storms are happening. And then what happens is you have the warm front and cold front meeting, and then from the south, it'll keep pumping warm air up. So you have this warm air that comes up, starts to kind of cool down a little bit because it's bouncing into this cold front. But then right behind it comes another wave of warm air, and it just keeps doing that for about a few days in a row. And as it does that, you'll see those occluded fronts attached to the warm fronts. It'll kind of wrap around the back side, and that's where it's just sustaining the system. That's why they just keep getting rained on over and over and over, is because you're kind of just keep pumping the system full of energy by bringing that warm air up, and it just keeps the flow going. So if you see an occluded front, you can typically associate it with bad weather, like your warm front. And also, when I see an occluded front, I'm anticipating that weather is not going to move out very quickly. Okay, so that's a key thing. Don't expect it to move very quickly. It's probably going to hang in there, because if you get the occluded front, it means you've got a system that, where they're just feeding energy into it, and it's going to stay. So, all right, looking at the chart, just to kind of summarize all these things. This is your typical weather chart. This is a surface analysis, also known as a prognostic chart. You can get them for the surface. You can get them for 12, 24,000 on up. I think it's typically every 12,000 feet they provide those. Really, what we're concerned with typically is the surface analysis, the low level. And just by looking at this is all I need to start my analysis right here. Just look at this chart. We can look at the forecast. I can look at the METARs. Yeah, that's great. Whatever, Joe Winter said on the news, that's okay. But this is what I want to look at right off the bat. And this was actually just taken here last week or earlier this week, when we had the bad weather come through there on Tuesday, I think. But basically, right off the bat, I see a series of low pressures. Okay, bad weather. I know there's bad weather coming, or the potential for, and I'm assuming it's going to be some warm air. Okay, and we have an area of cold, high pressure up here in the northwest, and this is now I do feel like the weatherman going, here we high pressure coming in, yeah. But this area of high pressure, basically, what it's going to do is it's going to push this low pressure out. But before it does that, this low pressure is going to do something for us, okay? And it did do something for us. Unfortunately, we're already through that effect. But notice these lines that go all the way around. You see these little black lines that are all over the place? Those are lines of what we call isobars. It's a line of constant pressure, okay? The line of constant pressure, as indicated by your pressure numbers here, there's the 1018, 1017. These are measured in millibars again. There's that international standard, okay? But again, if we remember 1013 is the standard, we can look and see 995 is lower than standard, so of course it's associated with a low. And there's a 1017, which is higher than standard, so there's a high pressure. So it should all correlate, just like we've been talking. But the key thing is that we're now going to get on the topic of wind, which is our next one we're going to get into a little more. But the wind has a drastic effect, or it correlates drastically with the isobars. Okay, it flows parallel to the isobars. So you see how the isobars running north to south here? Okay. Does anybody remember what direction the low pressure flows? It goes counterclockwise. So it's going to flow this way. So we're going to be pulling warm air from the south, pulling it up to the north. What happened on Tuesday, Wednesday? This is what was happening Tuesday, Wednesday. What was Thursday like? Nice and warm, right? We had that one day of warm weather. That it brought all that warm air up from the Gulf. That's how it did it. Okay, it's not magic. It doesn't just show up one day. The sun doesn't just warm up more one day than the next. It brings that warm air from the Gulf down here. Okay, now going forward, okay, and this is a current surface analysis back on Tuesday. Now I did my own analysis. I knew exactly what the weather was going to be like today. Okay, and you all know what the weather's like today. You had to walk in it coming in the door. It's nice and chilly. Why is it cold today? Do we have an idea? The Canadians came down, yeah. Okay, this big high pressure is gonna come down, and as it comes down, it flows which way? Clockwise. And as it comes down, it's gonna bring from up here. It's gonna bring the air down from the north, that cold Canadian air, the Arctic air, and bring it on down, which is why the wind's howling out of the northwest right now, and why it's 20 degrees outside. So this was back on Tuesday. and yet I know what the weather's going to be on Saturday. You know, I don't know exactly. I'm not going to forecast what the temperature is going to be, what the wind speed's going to be. There's those types of things you cannot forecast out. So when you're watching the 7-day forecast and he says next Saturday it's going to be 12-mile-an-hour winds, I'm calling him out. Yeah, it might be, but there's no way to know. You get 2 days out, and okay, we can probably get an idea what the wind speed's going to be, because we can start, because we doing our own analysis can look at the pressures and see see the shapes of the pressures and where they're at, and we can tell wind speed by the how close the isobars are. The closer they are, the stronger that wind's going to be. So if we look out here, see how wide these isobars are out here in the northwest, especially right here in the high pressure. There is no isobars there. It's empty. This whole area up in Washington and Oregon, it would have been calm wind all day up there. Okay, back on Wednesday, I guess it was, when it was blowing all day Wednesday out of the south, out about the southeast, it was howling, and that's because look at all the isobars and how tight they are all around that low pressure. Okay, so that just shows you the difference between the low pressure and the bad weather and the high pressure in that big open area of good clear weather. So, all right, talking about the wind, when we look at the wind charts, just to review, you know, these are the symbols you're going to see. A full barb is 10 knots, half barb is 5 knots. So this particular one would be 25 knots. That indicates 25 knot wind. If you have a solid filled triangle, that's 50 knots. Let's hope we don't see that unless it's our tailwind going in the same direction. You know, that's always good. I probably told half you in the room, but I've been bragging all week because Brian and I went down to Louisiana last week, and we had basically a 60-mile-an-hour tailwind going down to Louisiana in a Satabria, and we typically cruise about 120-mile-an-hour ground speed, and that we were doing 180 ground speed. That was awesome. I'm surprised we didn't just warp down there, but so you know, again, doing your forecast will make or break your flight. You know, and Brian and I were watching the weather a few days out, you know, 2-3 days out, and it you know, sometimes you get lucky, but we were watching, and we knew we were going to have that tailwind, and we also knew, because we were watching where the pressures were at and how they were going to flow through, that once that pressure flowed through that day, we're riding the wave going down. That night it goes past, and now we catch the wave coming back up the other way, and we actually had a tailwind going home. So tailwind both ways. It can be done. Trust me, it can be done. I've done it more than once, and yeah, it makes a world of difference on your flying. You know, I see guys that just constantly battle winds going the wrong way, either because they're impatient or maybe they just have to go. But if you have to go, that's called the airlines. Yeah, okay. So, and also understand that the public probably should understand that too. Sometimes airlines actually deviate, like we showed you on the map before. They will deviate out of the way, and if somehow the passengers are aware of that, they're thinking, you know, what is this guy doing? We're going to St. Louis to try to go to, you know, I'm not talking about connecting flights. That's a whole other issue. But as far as flying around, you know, they're probably, if they're doing it, which is rare, typically they just buck the headwind and they can throttle up down. But if they do that, they're trying to help you out actually. But most people don't know that. The Coriolis effect, if you recall that, deflects to the right. Just a reminder. It's a good thing to know that affects our surface winds and the typical wind flow. All right, we're going the wrong way here. Okay, so we're coming back, and we wanted to basically show you again, where those wind patterns were at and showing how it flows. So again, just with this one chart, I already know where all the wind patterns are at. Okay, I don't know what the winds, I have a rough idea of the wind speed on the ground. I have a rough idea of the wind speed up aloft. It will change, but I can already tell that if I'm going to Louisiana today, it ain't going to work very well. Okay, I'm going to be bucking a headwind. So now to show you this, let's look at an actual wind chart. Okay, and as we look at the wind chart, this is a surface wind speed, and you'll notice they put the pressure systems on here. We wouldn't need them because we can actually see them. You'll see the flow. Okay, the wind barb, and I should point, this indicates the direction it's going, so it's actually flowing this way. Okay, it's going from the tail to the head. That's the direction of flow. So just make sure that's kind of important to understand. So back to the chart, it's flowing around. You'll see the barbs flowing around the counterclockwise rotation and low pressure. Okay, and it's flowing clear down here, and you see the straight line. Look at that, just coming straight up from the Gulf all the way into Iowa. Okay, there's all that warm air coming up back on Wednesday. If we look at the high pressures, there's there's a couple, and when you get them mixed up, sometimes, especially on the surface won't show a real clear indication because things get shifted. Especially the more pressure systems you have, they intermingle with each other and it kind of can mess the flow up. We can still assume that you can still see here that the wind is between these high pressures, the wind is flowing around clockwise, typically, okay? It's it's an elongated, big oval there instead of a circle because of the fact that you have like, 4 pressures all in a line. It's going to flow all the way around them, but it will still happen. And of course, up here, you can see a little bit of a clockwise flow there. So if we're in South Dakota and we want to go to Texas today, that's going to be a great day to go to Texas. I mean, you're talking there's 20, 30 knot winds at the surface going straight south. Huge difference, okay? Just by looking at this chart, there's those winds. We can see that wind coming down. This air is coming down, and we know we're going to have a good wind out of the north there and wind out of the south there. Again, if we're up here, picking your side that you go on makes the difference. So just to show you, there's the some of the different rotations. And now if we look, this will move up to 12,000 feet, and we'll see that the winds start to streamline themselves a little more. The flows are a little more consistent. We don't get the erratic stuff as we see on the surface, because at the surface, below 12,000 feet, we have mountains and hills and other things that are going to affect and flow the wind different directions. So we get a little more of a, not as clear of a picture, but at 12,000 feet, it starts to streamline, and you'll still see there's your low pressure going counterclockwise. There's your high pressure. There's your high pressure. Okay, that low that was down in the Carolinas, and we set a big high pressure out here over the Atlantic. And so they're starting to streamline. Notice the velocities are starting to increase tremendously, okay? We're talking, there's a lot of 50 knot winds, 50, 60 knot winds right in this area. So again, if 12,000 feet and a lot of aircraft, that's typical cruising altitude, it can be. And now you went from 30 knots to 60 knots. So that's, that's not ideal. So another item to note is we notice this general flow from the west to the east, and it curves up and over. Does that look familiar to anybody? Jet stream. Okay, let's jump up to 36,000 feet. Okay, the winds typically increase as you gain in altitude, and now we have 50, 60 mile an hour winds all the way through here, and in fact down south we're actually getting into the 125 knot winds here. Now this is exactly why when you go from LA to New York, this is why you get there faster than when you go from New York back to LA. Okay, they got 125 knots pushing them the whole way. It makes a big difference. If your aircraft goes 500 knots and you now have a fifth more speed to you, that's tremendous, especially over a long distance. So, but again, what shape do we see? There's that same flow. So even down as low as 12,000 feet, you can start to see that jet stream flow. You can see where it's actually at and how it's affecting the area. And that's being caused by the areas of low pressure and the areas of low pressure that are kind of shaping that jet stream flow. It all correlates, it's all working together. So it's just our ability to see the big picture. That's what makes the difference. So any other questions on temperature, wind? No question? Yeah.
How does it work with rising altitude, the winds kind of shift around?
Basically, sure. As you gain in altitude, the winds will typically shift. Again, that Coriolis effect will have an effect on it, and that's always to the right in the northern hemisphere. But that also has to do with the pressure systems themselves. The pressure systems that we're talking about don't go to 100,000 feet. Okay, you'll notice because everything becomes more streamlined as you go higher, because the pressure differences are much more subtle. The only reason we have differences in pressure is, again, because we're heating the surface. The surface heats up, and it heats the air next to the surface. Then that air heats up, and it has to work its way back up through the atmosphere, which is, it can't go to 100,000 feet. It just doesn't have enough energy to do that. If it did, we'd have to be, a couple hundred degrees on the surface to get the air up there to be enough to make a difference in pressure. So the pressure systems actually die off, and as they do that, that causes a change in the shape and the flow. Because they kind of taper as they get to the top. They're not as strong. Occasionally, you'll get a really big high pressure. When like the whole country, they're like, boy, it's nice everywhere, except for like, Delaware or somewhere. It's just, they're just getting hammered. But somebody's always somebody's unlucky. But typically when the whole country is experiencing a nice day, That's because we get an area of extremely high pressure, just a big buildup where it really, especially from the Arctic, if it's been sitting up there and getting cold, and really builds up till then it kind of starts to slide down our way. It might be cool air, but it's going to be a nice clear day, and it'll affect a large area. So that answers the question. Yep.
Surface friction tends to slow the air too.
Correct. Yep. Down on the ground, you'll get that. That's on the ground. Anything from the surface itself, and as we all know, if you're trying to take off and land at an airport, unlike Independence, but other airports that have obstacles, tree lines along the sides of the runway, that will drastically affect your wind flow patterns. So even though the wind may be out of the northwest, you come down to try to land and it's 45 degrees different, which could actually change which runway you land on, even though that can kind of get goofy for guys. And if you're really unlucky, you try to come in and land and the trees actually block the wind entirely at the wrong time and you lose all your lift. Not speaking from experience at all. Okay, so let's move on here to pilot reports. We're going to talk about pilot reports and flight service, and those are kind of our last two major topics that we hit today. And I want to talk about these particularly because it's another area that I think a lot of pilots are not comfortable with, haven't had much experience with, or don't make as much, they don't take advantage of the system. Pilot reports, boy, I wish guys would do more of these. There's not enough of this going on. And it doesn't help. It's one of those things that the more we contribute, the more we get out of it. Pilot reports are reports that we give to air traffic control to advise them of what the weather conditions are. Okay? This doesn't mean we're going to go outside and stand and say, well, today it's 73 degrees and the wind speed is this much, and this is when we're taking off and flying, and we're specifically going to advise them of adverse weather or weather that is significantly different than forecast. Okay? Significantly different than forecast or hazardous weather, particularly. I mean, if there's icing conditions, turbulence maybe it was forecast, but maybe it is just really bad, and you want to let them know, hey, it's really bad, so you can let everybody else know. Maybe they'll change their mind about trying to fly today. Or if the icing is as bad or worse than they forecast, let the other guys know so they don't take off and some guy that's not quite as capable gets into a bad spot. So when we're giving pilot reports, a couple things to remember: use proper phraseology. We've all been taught how to talk to air traffic control. If you're not comfortable talking to air traffic control, that's fine. Go find an instructor and just practice. It's not a big deal. I think there's a lot of guys that could be making use of the services that are just simply scared away from talking to them just because they haven't done it. They just don't have the experience, and that's understandable. But go out and get the experience. Take an instructor along, or just sit. You don't even have to go fly. Just sit in the classroom and have the instructor pretend to be the tower controller and talk to you. It makes a huge difference. When you do talk, another pet peeve: keep it short. Okay, a lot of guys like to talk. We're pilots. We all like to talk, but keep it short when you're talking to air traffic control. They want to get the information from you, but they don't want to hear a story about what you did last weekend either. They just want to know the key piece of information, and of course, make it useful. Don't tell them items that are not useful. If the sun's shining and it's 70 degrees, that's great, but that's not useful to anybody. That's we can all see that, we all understand that. So don't report that. Report things that are actually important, like icing, turbulence, wind shear. If there's the cloud heights, the bases and the tops of the clouds. So you'll see we have a pilot report form, and these little symbols here are the ones that are in your knowledge test that you have to kind of memorize just enough to hopefully get that question right on the knowledge test, and then you forget. But you should memorize some of these. They're not that hard. There's only a few of them. I really highly recommend you memorize them, because your ability to read a pilot report is just as important as your ability to give one. Okay, and you kind of have to have both skills. If you're only doing one or the other, especially if you're only reading the pilot reports, you're not contributing to the system. You're just taking advantage of everyone else is doing the work for you, type thing. So, basically the location of where you're at, the time that you took the report, what altitude you're at, what type of aircraft you are, what type of sky conditions, was the visibility good or bad, the temperature, the wind speed, turbulence, icing, and any other remarks. Notice they're just key pieces of information. It's just very critical things. Now, do you have to report all of this? No. Okay? You give them what you need, and this is what we're going to go through. We're going to show an example here. You only need to give what's important, and you want to, again, keeping it short and keeping it useful. So in our example here, the aircraft calls flight watch, and he just gets a hold of flight watch, Cessna 1, 2, 3, 4, with a pilot report. And, you know, pause and wait, let the controller get their stuff ready to go. Sometimes they're on other frequencies, okay? Most of your flight service stations are monitoring multiple frequencies at the same time. Just because you don't hear anybody else on the frequency doesn't mean that they're not talking to somebody else. And if you keep calling them, hey, you know, listen to me, you're not going to make friends too quickly, because he's now hearing you scream in one ear, and he's got 10 other guys talking to him in the other ear, and he's trying to sort it all out. So, you know, I guarantee you 9 out of 10 times when you make your call, as long as you're talking nice and clear and loud and you're not too far from the station, if you make your call 9 out of 10 times, they heard you the first time. So just wait. They will get back to you. So don't worry. It's not a big deal. Just keep cruising like you were before. They'll call you back. When they call you back, he'll announce who he is, and he'll say, you know, go ahead. And at that point, when you give your report, start off with your tail number. I hear a lot of guys just say, you know, yeah, this is a Cessna, I'm over so-and-so. Give them your tail number. Just, it's not, you know, you're not going to get in trouble. Like, I don't know, I think guys feel like if you give your tail number, or it's got to be this anonymous guy out there flying around. Give them your tail number and tell them what type of aircraft you are, okay? Sometimes I hear guys do the opposite, where they just give the tail number. They don't give the type of aircraft. It's important to understand what type of aircraft is given the report, because if I'm in a Cessna 172 and I report moderate turbulence, okay, that means one thing. If I'm in a 747 and I report moderate turbulence, that's a whole nother thing, okay? Understand that the level, you know, we use the same terms, but they don't mean the same thing, okay? And if I'm in a Cessna 172 and a 747 takes off ahead of me and he reports moderate turbulence right off of departure, I'm going to rethink about what I'm about to do, okay? Because it takes a lot more turbulence to affect that 747 than it does me. So I don't want to experience that. It's going to be a lot worse. So let them know what type you are. Let them know where you are. This is very important. Let them know where you're at, and be specific. Don't just say I'm in Southeast Iowa, Northeast Iowa. Tell them where you're at. If you can't tell them where you're at, you need to hopefully figure out, well, you need to figure out where you're at. You need to land and figure out where you're at, okay? You're not doing your job if you don't know where you're at. And in our example here, he's on the Roswell 290 degree radial at 40 miles. Now, if you don't understand what that means, that's fine. Not everybody navigates with VORs anymore. And if you do, or if you're a VFR pilot, even though you may have been taught that, you might have forgotten it if you don't use it. But use the VORs if you can. If you can't, just tell them what airport you're near. Don't tell them you're next to Jackie's farm strip. Tell them that you're, you know, they don't know where that's at. Tell them, give them a major airport. And it doesn't matter if it's like right below you or if it's, you know, 50 miles away. If you're 50 miles, if you know you're 50 miles east of an airport, okay, like in this case, he's 40 miles west of this VOR, that's fine. That's an exact position. He can take the guy knows where the controller knows where the VOR is at. He's going to go 40 miles and go, there you are, right there, okay? So identify yourself based on a certified landmark, you know, an airport or a VOR or an intersection of some sort that they can identify. Identify what altitude you're at. This is important to know where you're taking your observation from. Is it right off the ground? Is it just off a departure? Was it on arrival? Was it you know, at 9,000 feet or 23,000 feet? If I get a report from a 737 cruising at 32,000 feet and he's reporting light chop, I don't care. If I can get to 32,000 feet, I got something else going on, you know. So let them know the conditions. Again, we have the turbulence, icing, and wind. Let them know what's going on. So light chop, if you don't know the terms, look them up. We have light chop, and then you have basically light turbulence, moderate turbulence, heavy turbulence. So light chop is going to be your like lowest form. It's like I feel a little movement going on. You know, it's not a whole lot. Which again, light chop in a 737 means a whole lot. Means that equates to basically light chop in a larger aircraft will be like light to moderate. It could be light or potentially moderate, but light turbulence in a smaller airplane. So there's always that transition, that difference. So temperature is -2. Scattered clouds above and around 25,000 feet. Okay. Now, Is this 172 at 25,000 feet to know that? No. Okay. But what's he letting everybody know by doing this? He's at 9,000 feet. He says scattered clouds above and around 25,000 feet. It's clear he's saying I'm clear until it looks like there's no clouds to 25,000 feet. So he's basically saying you got this much room to work with. You got a big area. There's nothing to worry about. That is important. Although to him it's not. He doesn't care because he can't get 25,000 feet. It is important because everybody else, that's a useful piece of information. Does that make sense? It's useful to everybody, not just the guys up at 25,000. And again, you don't need to be specific. I know, we don't have a rangefinder to sit there and shoot the clouds and see where we're talking, but if it looks way up there, and again, if you're out there watching those thunderstorms, like we've been talking about, you're going to start to get a better perception and idea of how high you're looking up in the sky based on what you see and the types of clouds and where they're at. And finally, he says he can see lower clouds and lightning to the north. Okay? Now, how could this have been this last piece been a little bit better? Lower clouds and lightning to the north. Where are the low clouds? Are they like right below you, way below you? Is there nothing below you but the low clouds are also to the north? It's kind of vague in his thing. Now, the air traffic control specialist is probably going to clarify that. They want to know, if they're doing their job, they're going to say, well, where are those low clouds? Are those, can you give me an estimated altitude or distance from you? So these are all important. But that's basically a good pilot report. Does that make sense?
That temperature they want centigrade or Fahrenheit doesn't make any.
Tell them what you're using. Tell them what you're using. Okay, Celsius is the standard, but use whatever you need to. Would you turn the temperature down a little bit? Everybody getting a little warm in here. It's kind of heating up now. We're all try to turn that down. Yeah.
Like if you don't know the clouds, like we say, lower clouds to the north, and that'll precipitate maybe a phone call to some air traffic control airport in that area, and then like how many people have been flying from NASA, say, base the clouds and get through them, So they'll call up that airport and say, hey, the next guy that takes off, get a base report for me or something. And that's when you get that phone call outside that radio.
Right, and I want to specify because a lot of people probably haven't even experienced that either. But basically, when you're flying, the way we get these reports is, like Roy said, that the tower will ask, if the jet's taken off last night, he'll say, give me a base report. That means tell me where you hit the bottom of the clouds at, or give me a tops report, which means let me know when you blast out the top of them. Tell me where that's at. Okay, and what spurs that question is because somebody, the controller, they got this pilot report. He might have called out there and said, hey, it sounds like you guys are getting some low clouds. Can you let me know where those are at so I can let my guys know who are headed your way of what to expect? So, I mean, they communicate. Just because the guy you're talking to is communicating with a lot of other people, and he has a lot of resources at hand to use in the form of being able to call each other and talk to get that information. So, yeah, and if they ask you that, if they, don't be surprised if you get a request for a tops or a base report. If you're not comfortable, if you're busy, just, unable, okay, you can always give them the unable, or just say stand by. It's very easy when you're flying, just as you're climbing up, even though you're that new instrument pilot and you're doing your first hard IMC flight by yourself and you're just stuck to those gauges, you're busy, but you can easily look over, and when you pop out of the clouds, you're going to know and just say, oh, that was about 5,000 feet. Okay, just keep flying. And once you get out of the clouds, you're stabilized and everything's good, you still remember that was at 5,000 feet. So then call back and say, hey, by the way, when I popped out, it was about 5,000 feet. Okay, that's a great report for him. Final comment on this. Again, making it useful. The example I just gave. Don't take off. Notice that it's 5,000 feet. Then fly for 2 hours and go, oh, hey, by the way, 2 hours ago when I took off, okay, I still hear guys that say, oh yeah, when I took off, it was 1,000-foot overcast. Well, then the controller says, okay, where are you at now? Well, and then you hear the guy give his position and where he took off, and it's like 100 miles away. It's like, okay, so you've been flying for at least an hour, or probably an hour, and it's probably changed quite a bit. So make it useful. So, okay, yeah.
I always tell my students in the habit of like, when you get VFR flight following, every time you check out the next controller, just report something. Just always tell them something, like Cessna, whatever, checking on 5,500 feet, like make sure, always get a habit of saying something about the air because it's really useful. The control on the ground has no idea what's going on.
Yep,
They were minimal, you know, they were kind of relying on you to get sure.
Yep, that's very good. Yeah, you want to let the controller know because they can't tell. So, has anybody worked with Chicago Center? Anybody around here? Okay, who likes working with Chicago Center? Anybody? Okay. Now they're good guys. They do their job. They just take it too seriously sometimes. But yeah, giving those little reports. You know, sometimes those types of guys, depending on the controllers, they may not want it. But you know, if I've been down south in the Southwest in Albuquerque. Albuquerque Center is awesome. If you're ever down that way, those guys are just awesome. You cannot get them excited about anything ever. They will call a 737 and then they'll call a 172 and then they'll call a Navajo and ask everybody, what's your ride like? Just because they want to know. And then they do that voluntarily just because they want to know, so that next time a guy goes through, they've got an idea for each guy what it's like. You know, I mean, they do a good job. All right, I want to transition here. We're going to watch a short video here on a weather briefing. This was just made here the other day. I've had some of these up before, but I wanted to redo it just because I haven't had a current one in a while. Basically, what you're going to see is this is a call to flight service to get a weather briefing. This is on the ground on your phone. You call it, say I'm flying from A to B and I want a weather report. This is a full standard briefing. How many of you have not called flight service? Anybody never ever called them? Maybe once, a couple of guys. Okay. Yep. Probably because you're still in the middle of training, or okay. Now, better question would be, how many of you have only called them once? Okay. Okay, your instructor made you do it the one time, then you never did it again. Calling flight service, I know they get the bad perception that basically you call them up, you need your briefing, and then you can just kind of go set the phone down and go cook breakfast because they just keep talking about stuff, okay? And 10 minutes later, they finally go, is that all you need? And you go, yeah, that's plenty, thanks, okay? Now, that's one way to get a briefing, but that's not a real, that's not doing you any good. We really need to understand what they're telling us to better understand what our flight's going to be like. Now, we can do our own analysis like I've been teaching, like I've been showing you today, to look at the charts and understand it yourselves. But instead of having to go to all the work, or maybe you're in a spot, you're out in Western Kansas, there's no facility, there's no weather computer to get the weather. Call them up, get the briefing. Here, this is going to be an example of what it sounds like. I've put together the charts so you can kind of start to see the charts. I want you to kind of try to follow along and do your own analysis as he's telling you what the weather is, okay? And we're actually going to watch it over here.
Welcome to Lockheed Martin Flight Services. Please press or speak your response at any time.
Briefer.
What state are you departing from or processing a NOTAM for?
Iowa.
Please wait while I connect you with a flight briefer.
Flight Service.
Yeah, good morning. I have a profile for November 733 Foxtrot Alpha.
733 Foxtrot Alpha. 172?
Yep, that's the one.
How can I help you?
I just need a full briefing. It'll be IFR today. We're going to be departing off of Kilo India, Bravo. And we'll be departing at 1730 Zulu. Cruising at 5,000, direct to Lima, Alpha Foxtrot, Purdue University. And that'll be 2 hours and 30 minutes en route. Yep.
Alright, right now for the adverse conditions, you have an air misfire for conditions along the entire route. The flight's going to be with us the entire day. Ceiling below 1,000, visibility below 3, and precipitation is missed. You have an air miss for turbulence along the entire route of flight that's monitored turbulence below 8,000.
I picked a good day for this.
Pretty much the entire day. And on your departure, they're showing an air miss for monitoring between 2,000 and 8,000 feet. Data levels are starting from the surface. And then pretty much once you get airborne, I was pretty much from Cedar Rapids until your destination. You look at it, air miss for monitoring
Now, this was a flyable day.
For them,
This was a flyable day. So
activity
this is a
right now,
practical
pilot
scenario.
reports.
You know, this could be flyable.
Pilot reports, you ready?
Yeah, go ahead.
Here's those pilot
I
reports.
had one over by Cedar Rapids at maybe 1 hour ago at 1,800. A BE-40 reported temperature -1 and reported some light mix icing. That was runway 27 final approach. I got another one here about 10 miles east of Cedar Rapids. And this was like at 15390 Zulu at 2,700. The E-145 reported temperature -4, reported light rain icing. I got another one here over by Dubuque. 1 hour ago at 1,800, a citation reported overcast. Temperature was 0, negative icing. They reported tops of the clouds at 3,400. I got one over here by Moline, about 10 miles
that day.
southwest of there at 14, Christian at 1545 Zulu at 6,000 feet. A PA-27 reported temperature -4, reported negative icing. Tops of the clouds were 4,000 feet clear above. And let me see here. I got one about 30 miles south of Midway at 10,000, 10,000 feet. A citation reported temperature was +3. Light rain icing from 10,000 up to 14,000. And temperature was
So, a lot of pilot reports that day. That's a little unusual to get that many.
That's all your pilot reports. Force NOTAMs. I'm just checking the runway closures now to departure and destination airport. And then right now for us TFRs. No TFRs along that route of flight.
Okay.
The weather radar, as far as any weather echoes right now, really nothing along your route of flight. Everything pretty much starts to dissipate for us, rain or snow. I am looking at a visible satellite. And a little bit, starting to break up just a little bit in the India Bravo area, but it looks like solid overcast is going to move it from the west. Otherwise, right now along that entire route of flight, you're looking at a solid overcast, and that is some low stratus, okay?
Okay.
So it looks like your tops are probably between 4,000 to 5,000 feet along the entire route of flight.
Okay.
Synoptically, you got that deep low pressure system in the northern portions of Illinois, cold front extending southward out of that. Showing your pressure gradient is strong at the surface, you can expect some strong winds out of the northwest, pretty much on departure, along the route of flight. Yeah, looks like you can expect some gusty winds, possibly out of the southwest on your arrival into Indianapolis. All right, let me see here. Right now, current conditions. India Bravo reporting automated. Surface winds of 320 at 16, gust 16. Christian wind reporting automated wind 320 at 16, gust 25. Surface visibility is 10. A ceiling of 1,500 overcast. Temperature 0, dew point -1.
There's that dew point.
Forecast. The weather right now, as you climb out there, it looks like they're forecasting 2,500 overcast, top to 7,000 feet. And then forecast the surface winds out of the northwest at 20 knots, gusting up to 30 knots. That's pretty much en route to the eastern portions of Iowa. I'm looking at the northern portions of Illinois, and it looks like they're forecasting 3,000 overcast, tops to 7,000 feet. But they're forecasting some widely scattered light rain and snow showers. They're still forecasting surface winds out of the northwest at 20 knots, gusting up to 30 knots. Then your arrival into the western portions of Indianapolis, and they're pretty much forecasting this afternoon 3,500 overcast, and widely scattered light rain showers. Forecasting the wind out of the west gusting up to 25 knots. The terminal forecast. Going into Lima Alpha Foxtrot, and I'm looking at pretty much from 1900 Zulu to 2300 Zulu. Forecasting surface winds of 28017, gust 30, unrestricted visibility, ceilings of 3,500 broken. And right now, your destination reporting surface winds of 23014, gust 22. Surface visibility is 10. The ceiling of 2,100 overcast.
We're almost done with the briefing.
Dew point 6. And I'm going to look at your ice. I got an ice severity map here, stand by. All right, I'm looking at 5,000 feet, pretty much along that route of flight, looking at the light chance of precipitation there, pretty much in Iowa and the northern portions of Illinois. But let me see here.
There's that.
And I'm gonna look over by Mesa City.
Tailwind coming down.
When you get a tailwind, with the northwest, I would say averaging about 30 knots along the entire route of flight. Okay.
Okay.
Yes, you got a little bit of tailwind. As far as your NOTAMs, do you need the airport NOTAMs coming out of India Bravo?
I have the NOTAMs for Independence.
All right, Independence, Iowa, that Lima Alpha Foxtrot, you need the airport NOTAMs there.
Yes, sir.
All right, they are showing runway 23 Pappy's out of service. Runway 10 Pappy's out of service. Then they got 2 unlit towers and a wind turbine farm in the area. Do you need that?
Yeah, I'll get those.
All right, the first unlit tower is located 4 miles east. And the height is 1,035 feet MSL or 373 feet ATL.
Okay.
The wind turbine farm is located 20 miles northwest. And the height is 1,234 feet MSL or 422 feet ATL.
Okay.
So probably going to be between 5,000 and 6,000 feet in the area.
Okay. All right.
All right, brother, take contact flight-wise, give us a holler report, and just have a safe flight.
All right. Appreciate it. Thank you.
All right, bye-bye.
Okay, so there's a full briefing. Now, that's a lot of information, okay? If you're not familiar with looking at the charts, reading the charts, understanding what they mean, that's all gibberish. That was 10 minutes of gibberish and didn't do you any good. So understand the charts and everything we pulled up there. I pulled all the respective charts up and showed you what you should be looking at when he's giving that information, or how that information, where he's obtaining it, okay? He can look at the same charts that you can, or I should say you can look at the same charts he is. There's no difference. They don't have any special information that you can't access. It's just a matter of that they have it all in one consolidated area and they have the ability to pull it up quickly in order to give the briefing. The other thing I'd like, go away with understanding or thinking about is that that was about 8 minutes, I think, for the whole briefing. So you as the pilot had to suffer for 8 minutes, but that poor guy has to do that all day long. So just think about that. All right. And finally, let's just talk about air traffic control services. VFR flight following. Let's see, actually, I just get a count here. Who in here is instrument rated? Raise your hand. Okay. Okay. And everybody else, VFR, who's not even VFR rated. Some of you might, yeah. So VFR flight following, even if you're an IFR pilot, we like to go VFR. We want to, on a nice day, go cruising and enjoy it. And so if you're using VFR flight following, this provides an additional service for the pilot. This is not just traffic separation, but it can help you in a number of ways as far as weather-related topics on your flight. Number one, when you're talking to air traffic control, they update you every time they hand you off to a new controller, or every time you go far enough along, they're going to update you on the current barometric pressure. Okay, that is not just so that you have something to do every so often. Okay, that's not the point of that. That actually is giving you information, and you should notice the trend of the pressure increasing or decreasing along your route of flight. It should correlate with the weather charts along your route of flight to know what was going to happen. And you've all heard the saying, or I hope you've heard the saying, high to low, look out below. Okay, that's another good reason to be getting those updates from air traffic control, or to be doing it yourself, because the barometric pressure, the changes from going from a high pressure to low pressure can drastically affect the proper readout of your altimeter. And so there's a number of good things to get from that. Use air traffic control frequently. Don't wait till it's an emergency. Again, this is, a lot of guys are nervous about talking to them. Just talk to air traffic control. If you get comfortable doing it, it is worth it. They're there to help you, whether you believe it or not. I believe that to be true much more than the FAA, but the typical. But no, that the air traffic control, they're there to serve you. Understand that that's the role. That's the same with anything. As the pilot, we act like we're the kings of the world, and sometimes we kind of are. We're up there flying along, and really, there's a lot of people out there that are trying to help you. Air traffic control, the FAA, the FBOs on the ground, your mechanic. Everybody else really is kind of serving you to get your job done. So keep that mentality. Sometimes you think you're the victim of a lot of things out there flying, but they're there to help you, and use the service. I just cannot stress that enough. Use the service. When you're talking to them, ask for help when you need it. If you're not sure of something, ask. Okay.
I heard some, I don't know if this is true or not, maybe you can confirm, but that also a lot of the air traffic control centers get their funding based on how many aircraft they provide service to. So actually, by you contacting them and getting flight following or whatever kind of services you want from them,
correct.
you actually can catalog that as an aircraft that they provide service to.
Absolutely.
Stay funded for the next year.
Absolutely. You betcha. That's very important. That's very true. If you're from the area, Waterloo has a control tower. They also have radar. They have approach and departure control, which is a unique feature that they are not really supposed to have, but they do. And I can tell you that many times when I'm up flying with students, even though we're in the practice area, I call them up, just say, hey, we're here. Can we have flight following? Just while we're in our little area. I don't really need them for anything other, they're providing traffic separation for us. That's always a benefit. But other than that, I don't really need them, but I'm still calling them, just that I'm always there. They're still using me. We keep in contact. They're used to me being there. And again, that's just helping their numbers too. So, and that's just so you know, a side note, all airports that receive federal grant money, one of the stipulations on how much money they get or whether they get money at all depends on how many movements they have at that airport. Okay. And a movement is a takeoff or a landing. So every time you come and do your touch and goes at airports, as long as it's an airport that has somebody that's actually keeping track of that, there's a lot of airports that are desolate, there's nobody around, but if they're keeping track of that, that's helping it out. So, I love when our pattern's full, but I also like hearing when everyone else's pattern's full. It's just good for the whole system. So get out there and just understand that when you're doing touch and goes, when you're out flying different airports, that counts for something. So, and this is an important one. Do not rely on air traffic control for weather. Okay. As we learned from our example earlier, down in Florida, sometimes they can see heavy precipitation. They cannot see a light rain shower. It will not pick up. They can see moderate rain showers. They usually get moderate, and they can get heavy rain showers typically. Now, that depends on the controller and where the radar site is located, the strength of it, what their scope and capability is. But they can typically get medium to or moderate to heavy precipitation. So a lot of times you can get that as an aid, but again, don't rely on that. If that's what you're relying on, again, that means there's probably some severe weather around, and you should have done your homework a little better than trying to ask them what's going on around you. So they're typically busy, and that's just a freebie, if they have time. So, and always be courteous. Again, they're there to help you, and if you're nice to them, they're going to be a lot nicer to you. If you really, snap off your radio communications, they're going to snap right back, and so talk slow, they'll talk slow. Just be friendly, especially if you get to know the guys. If you're flying in and out of an airport, if you're based at Cedar Rapids or Waterloo or Dubuque, and you're based there and you're in and out, get to know them. Like we said, we don't want to be talking about what the local news is, but by all means, give them a shout when you're taxiing out and say, hey, how's it going this morning? And you get to kind of build that relationship up with the local controllers. And even the en route. I know guys that fly frequently from Minneapolis to Kansas City. They're using the same guys all the time, the same center, okay? And if they're flying the same time each week or each day, they're going to get the same shift. And those guys get to remember your tail number, your voice, and I guarantee you, when the time counts, they're going to be there to help you, and they're going to pull some favors for you when you need it. And and that I know where that's helped some guys out. So that relationship is very important. You guys have any questions on air traffic control and anything? Anything it can be weather related or otherwise. As
more of a comment. One of the things that we brought up with Oshkosh last year, the EATC sessions that the FAA had, was that with regards to weather radar, they actually have a delay similar to XL as far as what they're seeing in their scope.
Exactly. Yep. And that's just like everything else. It's not when we transmit a signal off our transponder, that's us transmitting it out. Otherwise, if it's just a primary radar target, it's just them bouncing it off and coming back, and there is a delay on that. Just like there would be